Hello and welcome to this session. Today, we will come with a very interesting topic to be discussed, that is configuring the input-output pins of 8051 microcontroller and execution of a simple program by using them.
Objectives. At the end of this session, you will be able to identify the port pins in an 8051 microcontroller and enter the program in the microcontroller kit and execute it. Let's first see what a microcontroller is. A microcontroller is a small and low-cost microcomputer which is designed to perform the specific tasks of embedded systems. The general microcontroller consists of the processor, the memory, which includes RAM, ROM, EEPROM, serial ports, peripherals like timers, counters, etc. Now let's look into the pin description of 8051 microcontroller. Pins 1 to 8. These pins are known as port 1. They serve as an input or output port. Pin 9. It is a reset pin which is used to reset the microcontroller to its initial values. Pins 10 to 17. These pins are known as port 3. RxD pin or receive data. Function. The RxD pin is used for serial communication to receive data from an external device. TXD or transmit data pin. Function. The TXD pin is used for serial communication to transmit data to an external device. INT or external interrupt pin. Function. The INT pin is used to receive external interruptions from peripheral devices or sensors. T0 or timer 0 pin. Function. T0 is one of the timers in the 8051 microcontrollers used for timing and counting applications. T1 or timer 1 pin. Function. T1 is another timer in the 8051 microcontrollers used for timing and counting purposes. Write and read signals. Function. These signals are typically used for interfacing with external memory or peripherals. Pins 18 and 19. These pins are used for interfacing an external crystal to get the system clock. Pin 20. This pin acts as a ground or negative power supply to the circuit. Pins 21 to 28. These pins are known as port 2. It serves as an input or output port. Pin 29. This is PSEN pin, which stands for Program Store Enable. Pin 30. This is ALE pin, which stands for Address Latch Enable. Pin 31. This is EA pin, which stands for External Access Input. Pins 32 to 39. These pins are known as port 0. It serves as input or output port. Pin 40. This pin is used to provide power supply to the circuit, typically plus 5 volt. Next, we will look at the tools, equipment, and materials needed to demonstrate the port pins of the controller and configure the ports for input and output operation. For this, you will need the following: monitor or laptop 1 number, microcontroller kit 1 number, USB cable 1 number, FRC cable 2 numbers, FlashMagic software, and Keel Microvision software. Now we will run the program using the software called Keel Microvision software. Switch on the computer and open the Keel Microvision software. Now let's enter the program in the Keel software. Once you have opened the software, click on Project and select New Microvision Project. Open a new folder here and name it as 8051 Microcontroller, where we write a program. Create the file name as per the project. Here, it is named as Input-Output Configuration. Click Save to proceed. A tab pop-up appears to select the microcontroller. Here, we are using the 8051 microcontroller. Select AT89C51 from the database and click OK. Click No for the start file. On the left side of the screen, a tab called Project appears. Click on the plus beside Target 1. Now Source Group opens. Right-click on Source Group 1 and select Add New Item to Group Source Group 1. Select the ASM file since we are writing the program in assembly language. Name the file here. It is named as Input-Output Configuration. Click on Add to add it on to the Source Group 1. Now start entering the program in the .asm file created. org00h sets the origin memory address to 00h. Define a label named L1 to create a loop for the program. MOVA P1 is moving the value of the port 1 or P1 to the accumulator A. This port acts as an input port for the program. Now type MOV P2A to move the value from the accumulator to port 2 or P2. Now type SJMP L1. This line helps us to jump back to the label L1 that we have created. This creates an infinite loop. Now type END to end the program. Now navigate to the target and right-click and select the options for the target 1. Change frequency to 11.052 MHz. Select the box of the Use on Chip ROM. Now go to Menu and select the output. Enter the hex file name in the name of executable. Here it is Input and Output Configuration. Select the box of Create Hex File and click OK to continue. Navigate to the menu and select Translate and check whether there is any error or warnings. In the build output, it will show the number of errors and warnings. Now next to Translate, there is an icon named and click on the build target. In the build output, it will be displayed Creating Hex File from Input-Output Port Configuration. Input-Output Port Configuration, 0 errors, 0 warnings. Turn on the microcontroller kit after entering the program in the software. Now connect the laptop to the microcontroller kit using USB cable. Connect one end of the cable to the laptop and other end to the microcontroller kit. Now click Windows on the keyboard and type FlashMagic to burn the code. Now in step 1, select the microcontroller. The microcontroller specification will vary from kit to kit. Here we are using 89V5-1RD2. Now for selecting the COM port, click on Windows and type Device Manager. Navigate to ports COM and LPT and check the port number. Here it was COM20. Now open FlashMagic and select the COM port as COM20. It varies from kit to kit. Make sure the COM port is No before selecting the COM port. Select the baud rate as 9600 and interface as None, ISP. Now navigate to the options and click on the Advanced options. Go to Hardware Configurations and deselect the USE DTR to control RST. Click on the box of Erase All Flash to erase all the programs previously done in the kit. Now go to Step 3 Firmware and browse the hex file created and select the hex file. Navigate to Step 5 and click on Start. Now click on the Reset button in the microcontroller kit to dump the program into the kit. Connect the ports according to the program. Locate the ports, switch and LED in the kit. Use FRC cables female to female for connecting the ports. Here, port 1 is connected to the switch and port 2 is connected to the LED. Now click on the Reset button again to burn the program. Now toggle the switches to high and low to see the output in the microcontroller kit in the form of LED. When the toggle switch is set to high, the LED will be high, and when the switch is set to low, the LED will be low.
This brings us to the end of the session. In this session, we have learned to identify the port pins in 8051 microcontroller and enter the program in the microcontroller kit and execute it. Thank you for watching. We will see you in the next session.